Now that we understand the left-hand side of a formula, let's look more at the right-hand side of the formula. Much like the left-hand side of the formula is the area that's going to be governed or calculated based on a formula, the right-hand side now determines how that formula is calculated. Therefore, in an arithmetic or a mathematical world, A equals B plus C. B plus C being the right-hand side of the formula. Let's take an example. Let's look at our cube, future year model, and hit formulas. And let's take a look at what we can do with a formula. We'll build a simple left-hand side. Hit OK. Equals right-hand side. The right-hand side consists of many operators, functions, or references to other points within the PowerOLAP model. The first thing that you can do is you can apply arithmetic operators, plus, minus, divide, subtract, exponential, whatever it's called. All these functions are supported by the right-hand side of the formula language. There's also a set of functions supported by PowerOLAP that can exist on the right-hand side as well. These break down into general metadata functions, looking up using metadata within the formulas, logical operators, date and time format functions, text format functions, mathematical operators such as sine, cosine, as well as financial operators, calculating interest rates. The right-hand side of a PowerOLAP formula can consist of multiple actions or operations that you want to perform on a region of data. To begin this sample, I'm going to build a sample formula and describe some of the formula functions that are available to be used in the right-hand side of a PowerOLAP formula. To use a formula in the right-hand side, first we'll define a quick left-hand side, actual, equal to. Now, to use a function, simply look at the list of functions on the left-hand side of the Edit Formula dialog, and you will get a complete list of the PowerOLAP functions. The standard functions are broken out into several groupings. The first grouping I'm going to discuss are the logical operators. Logical operators consist of if, and, or type logic, the same type of logic that you can apply or use within an Excel formula itself. The syntax is very similar to that used in Excel, so those people who are used to using the formulas in the Excel syntax language will be most comfortable, or will be comfortable developing PowerOLAP formulas. The second set of functions are metadata functions. Metadata functions are specific to accessing and using metadata attributes or elements of metadata to perform calculations. Many of the functions that we provide for metadata allow you to look at and review or understand the structure of your metadata. For example, parent. There's a parent function that returns the parent of a particular member of a dimension. Or property. The property function allows you to return a particular property from a dimension. This allows you to use properties or attributes of your dimension to perform specific calculations. For example, you may have a property that tags a member along a particular dimension with a particular piece of information. You may want to perform a different calculation based on that particular property. By using the property function along with the logical operator if, you can perform logical operations or different logical operations based on what the property value is set to. Next, a point operator. A point operator is simply pulling a value from another location in either the current cube or a separate cube. A point is defined by selecting the two square brackets. In this example, I'll click square brackets, and I'll define a point by selecting a dimension and picking a member within that dimension. So in this example, I'm going to pick sales along the accounts dimension and Canada along the regions dimension. The value within the square brackets is considered the point. In this example, the right-hand side is going to be the current year model sales for Canada. A right-hand side that represents a point can live in either the existing or the current cube, or can come from a second cube. In this example, I will switch and pull a value from a second cube. Instead of current year model, I will use future year model. And as you can see, I can select the members along any axis of the dimension within that second cube. Let's move on. The next set of functions are text functions. Text functions allow you to perform textual concatenation or searching or text replacement of values from PowerOLAP. These can act either on members or on values returning from cubes. Examples are concatenation, which is simply the AND character, or write, the write function to return a certain number of characters from the right or left-hand side, as well as various other textual representations or textual functions. Along with those, we also have date and time functions. These allow you to do math based on date and time. In addition to supporting standard date formatting, PowerOLAP formulas also support the standard Excel 2000 and 2004 date formats. Next is the ability to create custom functions. To call a custom function, select the function called DLL call. The DLL call function allows you to specify a custom function that exists within a DLL that must be placed in your System32 directory. The parameters that are passed to that function call are passed as an array of variants. What you can do is within that call, you can use those array of values that are passed from PowerOLAP, calculate a value, a custom function, and return the result of that into PowerOLAP. The next one are cross-database formulas. Within PowerOLAP, if the cubes you are trying to access all live within a single database, you can write a single formula to access those other cubes. If any dimensions are shared within those cubes, PowerOLAP uses the knowledge that it has within one database that these dimensions are the same dimensions. However, when accessing data from other databases, a function is required to tell PowerOLAP how to go to that other server or that other database, get the values necessary, and return back to PowerOLAP. These functions are called dbRead and dbReadWrite. The second function not only allows you to read data from a remote or second database, it allows you to change and write values back to that database.